Good afternoon. I'm Rob Parker, founder of Nuclear for Climate Australia. Today, I'd like to speak to you about the use of nuclear energy and its ability to achieve ultra-low emissions in the Australian grid. On this image, we see world-renowned climate scientist Professor James Hansen, who has stated that the opposition to nuclear power is truly insane. This is the problem the globe is suffering right now. The Earth's energy imbalance is driving up the amount of stored energy in our oceans. This image comes from the National Oceanographic and Atmospheric Administration in the United States, and it looks at just the growth in energy that's gone into the oceans from 1960 through to 2024. Now, as we know, the oceans have about 100 times the heat capacity of our atmosphere. It is the oceans that drive atmospheric and terrestrial weather patterns. And they are seen in this image, which comes from the Goddard Institute of Space Science at NASA. On this image, we see the global temperatures that are currently existing compared to the period 1880 through to 1920. And so from about 1960, we got this continued rise. And at the end of the measured temperatures, we saw an accelerated warming projection in yellow. Okay. And that's where we thought the temperatures would be traveling. Unfortunately, the Earth didn't play that game. And so in the pink box, we see in 2019, where the El Nino temperatures actually drove us for that event. So the Earth is accelerating its warming. It is a big problem, and it's one we need to get on top of, but not in an hysterical manner. And so I put it that we need to be adopting the lowest possible carbon emitters of all generators to address this issue. And in this image, we see from the United Nations Economic Commission for Europe, a comparison of the life cycle emissions of all electricity generators. On the left-hand side, we have the fossil fuels. Far left, brown coal on about 1,100 grams. Then we have black coal on around about the 800 grams of carbon dioxide, coming through to gas at about the 400 to 600 grams. On the right-hand side, we have the renewables, with wind at about 13 or solar PV at about the 35. Of course, if we add storage devices like batteries or pumped hydro, it's easy for that number to get up to around the 70 or 80 grams of carbon dioxide per kilowatt hour. But they're sitting in the middle. The lowest emitter of all is nuclear. And why is that? Well, it's because nuclear is such a massive energy density that it doesn't require a lot of materials to be used to actually evolve that energy into the grid. And so it's got massive energy density and a very low environmental footprint. Contrast that with the problems that we're suffering from wind. Now, AEMO are telling us that in 2050, 46% of our electricity will be coming from wind power. And they're showing on this particular image, each vertical green column represents the output for one day in the month of May in 2024. The two red bands represent the efficiency or capacity factor, which we're told by CSIRO is applicable to wind, with an upper value of about 48%, a lower value of 29%. Unfortunately, in May of that year, things didn't go very well for wind, and it went down to 20%, not just in one state, but in all states, all across the NEM, from South Australia through to Queensland, down to Tasmania. Wind died. And in fact, it got so bad that on 7 days towards the end of the month, it got to 10%. Now, really, this is an unforgivable problem, because if we're to get to 46% of our electricity coming from wind by 2050, then you would have had to be importing probably about a quarter of all our energy in that month would have had to be imported from deep storages such as Snowy Hydro 2 or Barumba or all these large pump storages which aren't built. And that energy would have had to have been accumulated in the January, February, March, April periods. A very improbable possibility. Not only that, after this May event, you would have had to rebuild those storages very quickly to counter any subsequent events like this, because these things can happen quite frequently. And pity help us if the same thing had already happened in May. So I put it actually that we can never decarbonise with wind, because to do so, we need massive amounts of fossil fuels as backup for when the storages won't work, or we've driven the economies of our electricity into an unstable state. I'll pass now to this image where our analysis has compared 5 different energy scenarios, and we've looked at the actual emissions in these 5. On the left-hand side, the first column, and we'll forget about the column values, we'll just go to the solid red line and the dotted red lines on these images. So on the left-hand image, we have our energy system in 2022, which has dominated by coal and gas. And we saw in that period, our embodied emissions were up around about 713 grams of carbon dioxide, with burnt fossil fuel at about 684. If we move to the next one along, that's AEMO's step change scenario. We have embodied emissions of about 145, which is hardly ultra-low carbon, and we have burnt fossil fuel sitting on about 40. We have the progressive change on about 150 and 66 respectively. But the lowest emitters of all are the 2 nuclear scenarios on the right-hand side. One is a 50% scenario, second last column, and the last column is 75% nuclear, and that's sitting on only 34 grams of carbon dioxide on life cycle emissions and 0 carbon on burnt fossil fuels. So in summary, it is impossible to decarbonise with wind and solar alone. The embodied emissions are too high for them ever to become ultra-low emitters. And the excessive installed capacity and redundancy and all the transmission are the key drivers. On this image, we see the type of energy scenario that we've been looking at Nuclear for Climate Australia. This parallels that 75% nuclear that we saw in the previous image. So I'll describe this. On the left-hand side, we have the 2023, and on the right-hand side, we're going through to 2060. So we start off with about 200 terawatt hours per year. That's where we currently are in Australia, getting up to about 300 terawatt hours per year in 2060, which is somewhat similar to AEMO's progressive change. The colours represent black is black coal, the orange tone is brown coal, the dark grey is open cycle gas, followed by combined cycle gas. Then in yellow we have rooftop solar, in brown utility solar, in lighter blue we have wind, and in dark blue we have hydro, and in green we have nuclear. In 2050 we have 18 gigawatts of nuclear, in 2060 we have 30 gigawatts. But please focus on what happens with our emissions. As we come down from the left on the life cycle emissions in solid, we see 600 grams sitting in 2023. And when nuclear starts to kick in at around about the 2039 mark, emissions start to drop significantly from 422 right down to 48 grams in about 2050. Burn fossil fuel is almost nothing on about 3 grams. And on the right-hand side, we get down to 41 grams carbon dioxide life cycle emissions with 0 fossil fuels. And most of the 41 grams is coming from the renewables that are sitting in these scenarios. We've heard from outfits like the Smart Energy Council or the Climate Council or the ALP that if we go towards nuclear, then we are going to delay emission reductions and we're going to cause excess emissions while nuclear gets underway. Well, actually, the reverse is the case, and I'll explain to you that on this image. In blue, we have the cumulative emissions from the theoretical case for step change. So through until 2120, the emissions will climb steadily to 5.5 billion tonnes of carbon. But it's highly unlikely, of course, that step change will follow that scenario with the delay we're seeing in Snowy Hydro 2, with the Barumba deep storage plants in Queensland, or with the extended time taken to build the transmission lines. So if we add, for example, a decade to that, we'll see step change get out to about 6.1 billion tonnes. If we built nuclear in the yellow and the orange line, we'd see out around 2120, nuclear would be sitting on 3.1 billion tonnes, or about half that step change. So it is completely false to claim that nuclear will cause a problem of prolonging emissions. It won't. It will create a substantial benefit in reducing the emissions to our globe. My final image shows at this conference I attended in 2019, where I was honoured to represent the Australian Nuclear Association, where I signed up with the members of 25 other global nuclear societies to the Nuclear Innovation Clean Energy Future, where we all signed up to this desire to achieve ultra-low emissions with nuclear. And that's been an ongoing program that's worked very well, particularly within the European Union. So in summary, I can only endorse Professor James Hansen's claim that the opposition of nuclear power is truly insane. And I wish the Teals, the Greens and the ALP would change their minds. And please remember that our forthcoming election, we really do need to vote for the party who has advocated for actually a true ultra-low emissions generating technology with nuclear, namely the coalition parties. Thank you.